Greetings and welcome to my live demo. Today I'm going to demonstrate about how computer vision can aid in medical tasks like identifying skin lesions so that we can classify, for example, melanoma, which is also known as skin cancer. So to brief you on what I did, I used the SkinMNIST dataset, which also known as HAM 10,000, which contains 10,000 skin lesion data and their respective labels. So what I did is I used a baseline model and a transfer learning model to train on the 10,000 data, and then I augmented it with the lighting variations and the geometric transformation variations. So I want to focus extensively in this live demo on the SmoothGrad Saliency because it is important to understanding what the machine thinks. So right here, we have the original image and the SmoothGrad Saliency maps. As you can see, there are pixels where they are highlighted intensely red, and they are less intensive red. So what this means that the intensive part is what influences the machine to make a decision, a classification. So right now, the what we want is that the skin lesion is highlighted very intensive red, and then the surrounding skin is highlighted a little bit, but not so intensively. Why? Because you have to understand that the machine does not know that the image is a skin image. It may think that the image is some black stains on a red colored wall, for example. So in order to make it know that it is a skin image, we need to provide some context information. For example, this image, that is hair. So meaning that the machine sees hair and identifies, oh, this is hair. So that means this is skin. This is a image about skin. So this is what we want. We want it to highlight the skin lesion itself very deeply, but the surrounding skin not so deeply. So as you can see, judging from this model is not as good. It's not very good. It did not really achieve what we wanted, but only on some images. Some other classes, it may struggle a lot because probably because that I did not train the model enough, so it did not have a clear decision boundary. And second of all, the labels, the classes are not balanced. There are some labels that are quite dominating. So for example, envy is the one that dominates the model. So right now, this is not good because this region is just not the entire skin lesion is detected, but this is good because the surrounding skin has some information to guide the model to identify, but the surrounding skin is just guidance. The lesion itself needs to be the decision maker, the one that tips the scales on the final classification. So overall, the baseline model did not perform that impressively. So let's see about the transfer learning model. So the transfer learning model also suffers from the same problems for a few of the same problems. Maybe probably because I only trained it on 50 epochs, so the decision boundaries aren't that clear. So right now, this one is okay, but this part is suspicious. This one is a complete failure. It only detects the skin lesion, surround the skin surrounding the skin lesion, but not the lesion itself. We don't want that. So this is also this is also a failure, but this is a very good. The entire lesion is highlighted very carefully, and this is bad because it highlights the hair, meaning that the hair is the one that makes the decision, not the lesion itself, which is very dangerous because it may detect some hair and then immediately conclude that it is, for example, envy, which is not what we wanted. So accuracy does not really matter if something like this happens because it will be biased, it will be shortcut learning. Why shortcut learning occurs? Because it detects that hair is easier to calculate the loss function than the entire lesion itself, because the entire lesion takes up so many pixels. So it tries to find the shortcuts. We don't want it to find the shortcuts. We want it to go the long way. But you cannot entirely remove hair. I tried it using hair attenuation and hair removal using morphological operations. It does not work because the hair is so important in providing context information. Once you remove the hair, the machine seems that to forget that this is actually skin data, not a painting on the wall or a stain on the wall. We don't want that to happen. So it's not as easy as removing hair. We need either more data or more training time, I believe. So here, failure. Okay, although I believe that the data set is not balanced, that's why it's causing this much issue. And I only trained it on 50 epochs because it trains so slowly on 10,000 images. But so yeah, envy dominates the data set. That's why there is trouble with the decision boundary, I believe. So, but the thing is, okay, I inputted a few more images here because the runtime ran out, so I cannot demonstrate it live and see how it processes. But basically, I uploaded the image and then it shows the SmoothGrad Saliency for the transferred learning model and the baseline model. So this is the baseline model. It actually predicted quite correctly. Do note that I only use skin cancer melanoma to simplify the labeling and the prediction for the test. And then indeed, sometimes it works very well. For example, in this part, it highlighted the skin a little bit, and then the entire lesion is highlighted, and then the transfer learning model highlighted it way better. So actually, it we are on the right track. The machine is learning the right things. The only problem is maybe the decision boundary is not configured nicely. So either more data or longer training times. So this one is good. This one is also very good. So actually the model is quite robust. Okay, this is a bit of an anomaly because this is a facial one, so there's not much data for facial, but it actually did highlight the skin lesion. Only thing is maybe the labeling, which is a decision boundary issue. So for eyes, we did not have much data on eye skin cancer, eye melanoma, but it did highlight a little bit, but the decision making is over here, which is not what we wanted. So overall, this is actually a very good sign of the machine performing well. The only problem is we need me to train on more data. That's it. And then adjust the decision boundaries so that it gives a very more unbiased sort of, you know, unbiased result. So that is it for my live demonstration. I hope you learned a lot today. So take care, everybody.